Hello everyone, I'm Kaixin Chen. Today I'm going to talk about the cognitive load theory and one of its most important instructional applications, the expert height reversal effect. Here is a quickly overview. Let's move on to the first part, cognitive load theory. The cognitive load theory was proposed by John Wheeler in the 1980s to provide theoretical guidance for instructional design. It is based on the human cognitive architecture and consists for three main memory systems. The first is sensory memory. Receive stimuli from the environment with a very short duration. And the working memory is a core platform for information processing. It can only process a small amount of information at the same time because of the limited capacity. And for the long-term memory, once information is encoded as schemas, it is stored in long-term memory to support future learning. And also, Wheeler divided cognitive load into three types. The first is intrinsic cognitive load. It is related to the complexity of the learning material and determined by the number of elemental interactions handled at the same time. Teachers can adjust the difficulty by task decomposition and pre-knowledge teaching. And the next is extraneous cognitive load. It is caused by unreasonable teaching design or unnecessary information. It is not beneficial to learning, but consumes cognitive resources. It should be reduced by the clearly presenting information and avoiding interfering elements. And the last is germane cognitive load. It refers to cognitive processing that helps construct schemas and automate knowledge. It is beneficial to learning load, which should be encouraged, stimulated, and guided. It can also promote deep processing through analogy, guided questions, and cooperative learning. In this presentation, I choose elaborate on expert height reversal effect. It refers to the fact that as learners improve their knowledge level, some teaching methods that are effective for novices may become ineffective or even have negative effects. In other words, teaching strategies are not always effective for learners at different levels. So for the pure novices, they lack schemas, so they need clear explanations, steps, and examples to get learning. And the novices are more susceptible to redundant information interference. Two teaching materials need to be concise and well organized. And the integration of the text and pictures can help reduce the external cognitive load. And also, novices benefit the most from the demonstration imitation. But for experts who have mastered the structure of knowledge will feel that explaining too much. They performed better on exploratory and self-generating tasks, such as analyzing, reasoning, or coming up with solutions. They often depend on the original schemas to solve the problems. Experts are more inclined to use existing schemas for integrated thinking and reflective learning. So, how this applies in teaching practice? I choose the study of the contour maps in geography as an example. For the pure novices, their teaching objectives are relatively basic, and they mainly focus on the training on intentional map ability. First, teacher can show the top view of the real mountain and lead the students to ask questions. How can the terrain be shown on a flat map? And then introduce the definition of the contour lines. I made a diagram that can be used to show the correlation between the actual features and the contour maps in class. This allows students to intuitively understand contour maps, such as large spacing is equal to gentle terrain. The simultaneous presentation of images and text reduces external cognitive load. Next, teacher can use work example exercise to demonstrate step by step, such as how to judge the elevation and terrain in the figure. Students can also fill in some tasks along this way. For example, circle the top of a mountain on the map. Finally, teachers can set assessment for matching exercise and let students match the contour-mapped pictures with real skin pictures. But for experts, their teaching objectives are more focused on terrain planning analysis and practical problem solving. Teachers can import from real question and set up a situation for students. If you are a rescue planner and there is a flash flood in the area in the picture, how do you plan an evacuation route? Next, students judge the steepness and the direction of the road by analyzing the contour lines. And then teacher sets a task for students to design the safest evacuation route from village A to B. Finally, teacher can organize students to evaluate each other whether the path choice is the best, and put forward suggestions for improvement based on the landscape. So, the expertise reversal effect allows teachers to offer guided learning to novice and inquiry tasks to expert. This is helpful for differentiated teaching and cognitive load optimization. This is my reference. That's all. Thank you.